So in this video, we're going to look at composition of trigonometric functions along with their inverse trigonometric function. So remember, a function and an inverse undoes each other. So if you take the composition of f of x with f inverse of x, you're just going to wind up back with x. So what that means is it's saying that if I have the sine of the inverse sine of x, that's going to be equal to x. The cosine of the cosine inverse of x is going to be equal to x. The tangent of the tangent inverse of x is going to be equal to x. And these are all true for x in the domain of the inverse function. And they also work the other way. Sine inverse of the sine of x is equal to x. Cosine inverse of the cosine of x is equal to x. And tangent inverse of the tangent of x is equal to x. And same thing for all x in the range of the inverse trig function. So, for example, find the exact value of a, the inverse sine of the sine of pi over 4. So all that would happen here is the inverse sine and the sine would cancel each other out, and we end up with pi over 4, and we have to make sure, is pi over 4 in the range of the inverse sine? Yes, it is. So we're done. So here's another one. We could have the tangent of the inverse tangent of 0. And so again, the tangent and the inverse tangent would cancel each other out. And so when they cancel each other out, we just get 0, and we want to know, is 0 in the domain of the inverse tangent? And it is. So we're okay there. But it's not always the case that stuff is in the range. So for example, if I'm looking at the sine inverse of the sine of 2 pi over 3, here 2 pi over 3 is not in, so that's a mathematical way of saying it's not between minus pi over 2 to pi over 2. So in this case, we actually have to figure this out. So I'm just going to first work on the inside part, so the sine of 2 pi over 3. So that's saying that the inverse sine, the sine of 2 pi over 3 is actually root 3 over 2. And now I need to find the inverse sine of root 3 over 2. So remember, we're going to set this equal to theta. And we're saying that the sine of theta is actually root 3 over 2. And so if you try to figure out where the sine of theta is equal to root 3 over 2, in quadrants 1 or 4, theta actually turns out to be pi over 3. So when you get something that's not in the correct range, you have to actually figure it out. Once in a while, you might get something where you can't figure it out. So something like this. So the sine of the inverse sine of 4. So remember, 4 is not in the correct range, and 4 is outside. So the sine is always between minus 1 and 1. So this actually has no solution. So this has no solution because I should really say the sine of theta can never equal 4. It's just outside of the range.